recording. Hello Abdelmamoun, Abdelmonem, Bin Alfeu, Nangasi Harp, Aroma, Honikin. Honikin, I hope you feel better. Please guys, pray for Honikin too. He's feeling sick. Mititi, hello, G_M, Jarabi, Jealous, Joyzy, Monity, Pacman, Pascal, Rokia, Sabah, Shadow, Shaza, Somzi, Special Character, TD, Chui, Senji, Omar. Oh, we have two Omar today. Omar Day. Okay, so what we're gonna do today, like we did yesterday, Jealous, you have mic echo. If you can mute your mic, please. First, don't be shy to like write hello in chat. Just write hi and maybe react to some other hi. Who is doing this? Nyangasi, must be Nyangasi. Okay, so today we have this tree LeetCode. So we did yesterday this tree, right? And now we have this tree and we can go on 3 by 3. So let's start with the best time to buy and sell stock. Let's go. To see the chat. What's going on there? Let me do this. And this. So the first LeetCode is best time best time to buy and sell stock. You are given an array prices where prices E is the price of a given stock on the day, on the E day. You want to maximize your profits by choosing single day to buy one stock and choosing different day in the future to sell that stock. Okay, return the maximum profit you can achieve from this transaction. If you cannot achieve any profit, return 0. Okay, it's a bit tricky to understand. Let's see the code, or like the example. So they give us prices 7, 1, 5, 3, 6, 4. We should return 5. How did they do that? So they buy on day 2, price 1. Okay, so day 1 the stock was on 7, and in day 2 the stock was in 1, so they buy on 1, and sell on day 5 the price was 6, so they just wait this day until it's become 6 and they sell. Profits they make is 5. So we can think of this like someone can read the future or can see the future, and he was like, hey, the next day gonna be stock 7, the next 2 days gonna be 1, the day 3 it's gonna be 5, 3, 6, 4. So you see which day you wanna buy and which day you wanna sell. So if we can see the future, of course we're gonna buy when stock is 1, and we're gonna wait until it becomes 6 again and sell. We can't sell when it is 7 because we buy when in day 2. You can't go back in the past. Note that buying on day 2 and selling on day 1 is not allowed because you must buy before you sell. Okay, so you can't buy in 1 and then sell in 7. Okay, let's see this example. We have this array braces again 7, 6, 4, 3, 1. Output is 0. In this case, no transactions are done and the max profit is 0. Why? So maybe because they buy in 1.
Yeah, you buy in 1.
Yeah, they buy in 1. Yeah.
There's no subsidy after day 1. So.
Yeah, the list is in descending order, so there's no rational place you can buy then expect to make profit.
Exactly. You can't go back. So it's always a forward thing. So
Okay. Who have question about this problem? If something not clear, please don't be shy. You can open mic, talk, write in chat. This is your space. Okay, let's copy this and jump to LeetCode as always. I mean Excalibur. Dun, dun, dun. Let's see what's gonna happen here. Okay, how we can do this? Brainstorm. Brainstorm. So we have 7, 1, 5, 3, 6, 4. And we want to return, in this case, 5. We want to return 5 because 6. Oh, what's happening? Because 6 minus 1 is 5. Because this is the lower number we found, and after we found the lower number, the max number we found is this. So it already have that feeling that we kind of have 2 pointer, and one is like checking for the lower number in the array, and one is checking for the max number or something like this. And then we keep comparing this with this with this, and maybe if we find another lower number, let's say for example this was 2 and 1 was here, then when we're gonna move here, this gonna be like our lower number, something like that. What do you think, guys? What's comes to your mind?
The day you buy, from that day you buy, you start looking for the day to sell.
Yeah.
You understand? So that is why the second pointer, like you said, is dependent on the first. So when you are able to find a day to buy, then from that day you buy, you start finding where the day to sell that has the best value, so that you can have a good profit. You understand? They could have actually sold it in the second day, in day 3, but I mean the second day, which the third day, sorry, that's 5. But the profit was not, they still had a better value at the front, which would have given them more profits. So that's why they had to go further to look for the higher, the maximum value that will generate more profits for the person doing the business. So that's it. I think that's the idea.
Pascal, you give me now an idea, and I don't know if it was your meaning also. I don't know if it is rational or not, but what about of directly find the minimum number in this array to make it our buy day, the day we buy?
Exactly.
That's you mean. I think I understood this. And starting from this day we buy, we can apply whatever algorithm we search for the minimum, the maximum difference, right?
Exactly. That's
okay.
It.
Great.
Okay, I see 2 ideas in chat. Sliding window, and there's this one right here. It's using like min-max. So the main of the list,
the max is it's not in order. It's not gonna take in consideration which one comes first. The min might be after the max.
Oh, yes.
Exactly. That's why I say that the day you find the minimum, that's from that day you start for the maximum. Yes, she's very correct.
That's a good point. You can't just do min and then let's say this is 2 and this is wait, but it is the minimum, right? It's because if wait, okay, something is missing here. I think this may work, but I know it's not gonna work, but I don't know how to think about. So like, what is the, if we put it like this, what is the min? Is 1, right? So min gonna be 1.
Sorry, if you're looking for the minimum, you also have to look for the index of where you got to the minimum. You understand?
But I'm just gonna return the profit. So I'm gonna do 1. I'm gonna use the value. I'm not gonna return the index of the day.
No, what I'm saying is, what about if the minimum is in the last index?
Okay. Oh, okay, now I see it. Yeah. This case right here. So I need to return 0. Yeah. Yeah, if if it is in the last index, it's gonna return 1.
Also,
so we can
the minimum is not always the buy day.
That's another point. Very good point. Yes.
Okay.
Can we try this? I was thinking we can go through, or can we go through the list 2 times?
2 times, like loop first time and second time.
Yes. Is that allowed?
I think we are free. Let's see. I don't think they return the maximum. I don't think they mention any time complexity or something.
Okay. So we can go through. We can go through the list twice. So when we go for the first loop, we are going to get a particular variable. So assuming we get 7, we are going to get the variable and the index. The value and the index. So we'll be using we can use enumerate for that. When we get the value and the index, in the second loop, the inner loop, we start from the next item after we start from the next item. So we are going to compare. By then we must have initialized the maximum value to 0. We just initialize the maximum value to 0. So we are going to compare if the difference between, so then let's put it so we can understand.
Okay, so
go to
like with 2 pointer, we're gonna loop with 2 pointer or 1 pointer?
1 pointer, not like really, not the yes.
Okay.
So
okay.
we go through the loop, the first loop, and in the next loop, okay, maybe like a 2 pointer thing, like a 2 pointer thing, yeah.
Okay.
In the next loop, the next loop, we start from the second item. We are going to compare if the difference.
Let's give them a name. Let's say this is left and this is right. Left, right.
Okay. So we are going to check if the difference between left and right.
Left and the right. Like if like left less than right.
Yes.
Or I think you mean right less than left. So like. Right?
Yeah.
We're looking for minimum.
Yes, if right, yeah, the difference between right and left. So if it is greater than the max value.
Wait, let me zoom a bit.
We must have initialized the max value to,
let's say, buy.
0.
Now we're looking for a buy, right?
Yeah.
Okay. If right is less.
Okay. Let's get it this way. We are doing 2 loops now. So the first one, the first arrow there is the day we buy. The first arrow there is the day we buy.
So we can do it. We're gonna buy. It's gonna be always in index 0. Buy.
It's the day we buy.
It's like.
Are you sorry, you're saying that the first loop will be the buy loop, the buy day loop, right?
Yes.
All right.
And the second is going to be the sell day loop.
Which I think there's a way we can do it in same loop. Because these pointers are moving together, right? They're moving together. This is not gonna move to the end, then this gonna start moving.
It will. That's how I implemented mine. It will.
Yeah, I understand why he's saying that, because you know that the buy day is always in the past.
Yes.
The buy day is always in the past. So and the sell day is always in the future. So I think that two loop will work, yes. But if you have another method anyways, like he wants to, fine, we can use another method. Like, but it's okay. His own method as well.
Can go with a single iteration. But if we are going to a single iteration, we'll have to initialize some other values.
Okay, there is one loop way here.
Yes.
So for price in prices.
Yes.
So wait, in this case we compare max profits with the current price profit. Compare current price with the main price. Okay, I think I get it. Okay, so in this case we have max profit value. Max profit, let's call it MP. And it starts with what? 0?
0, yes.
And the main profit, I see they're both. So they're both max profits, and then the main price is what? Main price. So main price in this case is gonna be 7 because index 0, and then we're gonna loop. In our loop, what's gonna happen? The first time we're gonna go to 7. We're gonna compare max profits, which is this right here, 0. Compare this with current price profit. Compare the max profits with current price, which is 7. So we're gonna compare 7 with 0. Okay, maybe we should update the main price before to compare, because maybe okay, maybe
we'll end up having 7 at the.
Okay, maybe we do. We need to check first if this is less than this. So if price less than main price. If it is less, that means we should update the main price, right? Because we're looking for the lowest main price. So main price gonna be equal to the price. I think this is what is right in here. Compare current price with me, but I think this should be here before, because before I calculate the profit, I need to make sure I have the lowest, or maybe it doesn't matter because we can go. I think it does.
You need the minimum price, really. Like, you need to get it. You can't get a profit. It's just like telling me that you want to get a profit when you've not even bought an item.
And then in same loop,
the minimum price first.
We're gonna calculate the maximum profit. Now to calculate the max profits, we're gonna do the price minus the minimum. So the price minus the, but we only, okay, so we're gonna update the max profits if it is bigger. So we're gonna do. We need to check if 7 minus min price, is it like bigger than the profit that already we have. So the max, we can use the max here, this one, the max. So we can like do max profit and P price minus min profit and max profit. Let me zoom in, sorry. So something like this, which is gonna give us always the max profit. So max profit, so we did use max to update the max profit. Max profit, the value that was already there, first is gonna be 0, then we're gonna do price minus min profit that we update here. Wait, we actually can use the min here too, right? I think we can use the min. We can do like min profit equal min profit. How we can get how do we get min profit? We do price minus I forgot how we calculate the min profit.
So technically is the min price, so it's compared the previous minimum price with the current price to always have a minimum like buy date.
So we do, I forget the formula. Is it price?
Yeah.
You said price less than min price or something. But I guess it's like she said, it's left and right. You are doing the left and comparing them. If it's less, then you set the min price to the less one, the one that has the smaller value.
Wait, it's just price, right? It's just price because we are looking where, so price price was 0, right? When I'm gonna go to this, the price is 1, so automatically this become my main price. So I put it here, 1. Right? And then if I go again and find another main price, I put it here. So main profit is gonna be the main of comparison of these two, the main price and the price. Okay, let's write this in the readable pseudocode and see if it's gonna simulation work.
Are there cases where they give 0 price? Because in case there are cases like that, you need to handle it. A 0 price. Because if you say minimum, it will pick minimum as 0 if there's a 0 price actually in the array.
I mean, we're gonna return 0, right?
No, I mean that is there any case where they will give 0 in the price list? If there's no case, then it's fine. Like 0 will be among the price.
Oh, okay.
I don't know if the case like
there can always be. Can always.
So
No, they can't be. They cannot.
It can be 0, yes.
There can't be a 0.
Can you repeat? We can do check here.
Yeah.
We can do check.
I don't see the issue with the price being 0. If it's the minimum price you can have, then might it be?
Oh, okay. Maybe that stock is free that day, so you can buy it.
Yeah.
No, 0 price does not exist.
Yeah, I don't think 0 will work, because how will you buy if it's 0? It means you cannot
maybe
buy.
a discount or something.
Discount is 0.
It was a free day. free
Probably you just use a check there in the follow.
Okay, so this is actually work. Please, if someone have question or not answer, we can like just say it. Let's do simulation, see if it's gonna work actually. So price, we have price for price in price, so we have this gonna keep looping. And before we're gonna do max price, max profit, we call it max profit, right? Max profits, we're gonna call it 0. And min price, like what did we call it? Min price? Min price.
We can
price.
Yeah, we can forget about initializing it since we will initialize it before using it.
0, right? Because it's gonna be always the first one. Our min price always the first one, and we are moving and we changing it until with the lower one, right? Let's see if it's gonna work. So in this case, min price is 7, right? Is 7, and the max profit is 0. Now we go to the for loop. We loop 7. We see min price, the minimum between min price, which is in this case 7, and price, which is 7. So it's gonna be what? 7, I guess. It's gonna stay the same value. Then in same loop, we're gonna do max profit. It's gonna be the max of max profits, which is this, which is 0, with price minus min profit. So price, which is the value 7, so 7 minus min profit is 7, which gonna be 0. So max profit is gonna stay be 0. Now we're gonna loop again. We're gonna go to 1. 1. Let's see how it's gonna work in 1. Now.
Sorry, Daniel.
Yes.
Okay. Where did you initialize minimum profit?
Yes. Max profits in the min price.
I mean the minimum profit. Where did you initialize it?
There is no minimum profit. There is max profit and the min price.
I'm saying max profit. I'm saying price minus minimum profit.
Yeah, this is a mistake. Min price.
Okay, thank you.
No, thanks to you. Okay, so now we did go to 1, right? Now 1, the second loop, it's go to min price. Now the minimum between min price, which is 7, and price, which is 1, it's gonna be 1, so this gonna become 1. Okay, it's working. Now we have the by day, which is 1.
Yeah.
It's gonna go to the second line. Let me group this. Gonna go to the second line, which is max profit. What's gonna happen is the max between max profit, which is 0, and the price minus min price. Price is 1, and the min price is also 1. Now if we didn't have this line here before, if we didn't have this line before this line, it will be 1 minus 7, because the previous main price was 7.
Yeah.
Now we did 1 minus 1, it's gonna be 1, so it's gonna 1 minus 1, so it's gonna stay be 0. Let loop again. Let's see what's happened. Again, we're gonna loop. This is gonna be to 5. The minimum 5 and 1, that's gonna change. It's gonna still be 1. But when we're gonna go to max profit, let's see. Max profits between price is 5 minus 1 is 4. This gonna give us 4, and the max profit is 0. So the max of this is 4. So max gonna become 4. Okay, now we have a new date to sell, 5. But because the loop is not finished, we're gonna loop again. Now this is 3. 3, when we are in this line, nothing gonna change because 1 is still the minimum. We're gonna come here, then max profit we have is 4, and price 3 minus min price 1, it is 2. So the max is still 4. Nothing gonna change. Again, we're gonna loop to 6. 6 with 1, it's not gonna change the min price. and the profit's gonna be max profit is 4, and the price minus mean price is 6. 6 minus 1 is 5, and 5 6 minus 1 is 5, and 5 and 4, 5 is bigger, so the max profit is gonna become 5. Again, we're gonna loop. It's gonna come here, 4 and 1, the mean price is not gonna change. And the max profits, it's gonna be max profits 5, and price 4 minus 1 is 3, not gonna change it, it's gonna return, it should return 5. So here, it's gonna be return max profit. Okay, I think it's working fine, but maybe there's some edge case that we didn't think about. You can skip a useless chain by...
Yeah, I think it's working. Try for the second one. The second one they gave you, the one that goes in descending order.
Oh, that's actually true. So we can skip the first one, right? One. Because
can you
we
even
start
try
from
inserting
7.
a 0 there?
Can you repeat?
Yeah. Can you try inserting a 0 in between the array and C? 0 is one of the prices.
So right here, for example, or like here. We do it right here.
Yes,
this
yes, yes. Yeah.
Okay, let's remove this noise. So now we have change in the array 0. So this what's supposed to give us. So I'm gonna buy in 0. I should buy in this and sell in 6, right? And profit is gonna be 6.
Yeah.
So I don't think it's gonna change, it's gonna work fine, but let's do simulation. Let's say 0, and we start with 7, then we add this price 1 colon, so it's gonna start from here. Now 1 compared to 7 is gonna be 1, so the main price is gonna change, it's gonna become 1. Now the max profit.
I have a question.
Yes.
I have a question. When you put an index in the for loop, would that change when you are moving to the next? Like when you are looping through the list, when you put a 1 there, would that continue from there, like 1 to, it's going to go to the next list every time? I'm just asking the question. I've not tried this before.
This one.
That's what I'm asking.
Yeah.
Yes.
If you remove it, it's gonna start from here.
Will it continue? Okay, it's going to continue to the next like that. Even though you put 1 there, it's going to continue to the next.
Yeah. So this one is saying, hey, starts from here. Starts from index 1.
The next. Okay. It's fine.
Yeah, it's
Thanks.
good. But you can do like, if you don't, you can do like 2 or 3. So this is the limit from the right side.
Yeah. Thank you.
So 1 is here. It's gonna update the main price. Now the max profit is gonna be 0 here, and price minus main price. So 1 minus mean 1. It's gonna still be 0. Nothing gonna change. We're gonna go to the next one. It's gonna all be minimum of 0 and 1. So this gonna be 0. And it's gonna go to the max profits. Max profits is 0. Price 0 minus main price 0 is 0. Nothing gonna change. It's gonna go to here. It's not gonna change the main price. And the max profit gonna be price minus main price, which is 3, right? 3 minus 0. So this gonna be 3. Now we have new max profit. We're gonna loop again. Loop to 6. And again, main price gonna stay the same, and this gonna become 6. and we're gonna go to 4. Mean price gonna stay the same, and this gonna be the max of 4 and 6 is 6, so it's gonna stay 6. I guess it's working fine with 0. Please, if someone have a question.
So assuming this is an application and it's going to the market. It's going to the
market without no cash.
Will it pass quality assurance? It will never.
They will chase you away from the market.
Okay, let's work. Let's submit. Let's submit. Oh, nice. Let's clap for this teamwork.
Nice job, nice work.
Okay, now that we solve it, what is anyone have any question, pseudocode, not understand or anything? Please just write something in chat. Let's jump to the second LeetCode if there's no problem. Okay, anyone have any problem or question? Okay, should return 2. Okay, you guys discussing some idea, maybe we can join you. So what was the question here? What value do we need to return in those cases? Not buying at all, or just return the max negative value? Okay, which one? This one? This one. So this one 7643. Yeah, this one is gonna return 0 because this example right here, they say in this case no transaction are done and the max profit 0 because the list day to buy is at the end, so there's no day in the future to sell. Okay, yeah, I can share. Here is it. Okay, let's jump. So we have 2. We're gonna do them, both of them. We have 2 more. So there is valid palindrome, and there is invert binary tree. Which one we do first? Palindrome tree invert. Okay, the one that have more star, we're gonna do it. Palindrome or invert tree. Okay, palindrome. Let's do palindrome. So a phrase is a palindrome if after converting all uppercase letter into lowercase letter and removing all non-alphanumeric character, it's read the same forward and backward. Alphanumeric character include letters and numbers. Given a string S, return true if it is a palindrome or false otherwise. So, first example. A man, a plan, a corner, Panama. True. Wait, how is this true? Explanation is a palindrome. Okay, so they remove all the space, the comma, colon, everything. It's become palindrome. Okay, and they convert it to lowercase. Okay, is it? This is really palindrome? Check this example.
Yes.
Yeah, it's a palindrome. So you just remove the characters, make it a small letter, reverse it. If it's the same, yeah, return true.
I mean, that's the most straightforward way, but I mean, I guess you can do it where you can like split it in the middle and compare them. That would like save some time.
Yes, that's another method.
Okay, yeah, it is a palindrome. Okay. Now we can split them in the middle. What was the other idea?
Just reverse the entire string and compare.
Okay. Let's see. Let's see how we can do it. Let me take screenshots of this. So we can, let me copy this better. So first we have this string, right? And then we need to convert it to lowercase, so it's gonna become like A, and somehow we need to remove all the spaces and this stuff from here. To become like this, then after like this we can process it, because it can have like 1, 2 comma here and here, like just 3 comma or 5. It's still gonna count. So like this, then we reverse it, and compare, right? Or we can do 2 pointer and just move 1 pointer here, 1 pointer here, and keep going until we reach the middle, right? Let me post it. Okay, which idea we do? Do we reverse? Do we do 2 pointer? Which one is more?
If we are using a higher level language like Python, I think reverse would be available.
Reverse.
Yeah.
I don't know if it's allowed, but you can check if it's alphanumeric. I think Titan has an alphanumeric check.
Yeah.
Then there is a reverse also. You can reverse the whole
string.
String, yeah. But
so is alphanumeric return true if character is alphanumeric character? So this can be useful when we are looping with pointer, right?
Yeah.
But if we reverse, how we can reverse? If we wanna reverse, we had to clean it first, right?
Yeah.
So I don't know how we can do that.
First, we check for we do the alphanumeric, then we convert to lowercase, then we reverse it, I think.
But alphanumeric is just gonna return true or false. It's not gonna remove characters.
No, it will only allow us to convert or to check or to convert to lowercase if it's alphanumeric only, not the special characters.
I think we're gonna convert to lowercase in any way. Like we're gonna always convert to lowercase. Either it was so like here. Where's this one? This one. We're gonna like convert it to lowercase, this S, right?
Yeah.
Now this is unknown. If someone is new to him, we can do this. Let me zoom. So if I did A, it's gonna return true. If I did 1, it's gonna return true. If I did space, it's gonna return false. Or like comma or any character false. So this can return true only if if this character is like a letter or number. Okay, that's a good idea we can use. There's another idea: remove all non-alpha from string in Python can be definitely done using rigor with the model in alphanumeric characters. Any character that is either letter. Okay, this is also idea. We can like
Shaz's idea is a good one.
We can like remove all the character. Loop through to clean up, convert lowercase. Oh yeah, we can combine this. So what we're gonna do is like loop through. Wait. Loop through them. Okay, so we can create a new string. Like create a new string, right? So we're gonna check this character. If it is alphanumeric, add it to the new string. Come here. This is space. We're not gonna add it. This and keep going until the end. And then we reverse it. And we'll compare.
Yeah, that's the idea.
What about this resub? How does it work? You can ask ChatGPT how it works. Clean string from. But there is too many characters. How do we know? Oh, okay. I see. Someone writes it here. So this is a regular expression. If someone doesn't understand it, it's okay. So this gonna clean this string. Let's do a test. Okay, so test here. Now, where is our string? String. And input string. Print result. Lower first. Okay, so string that lower string, and then we can remove this. Run. I think I did some mistake. Oh, import.
Do I have to import?
Import.
Yeah, it has to be imported.
Okay, it did clean it. Okay, we can do this and then check if string equal string. What is the reverse? Reverse? Print. String dot.
Yeah.
So dots -1.
No,
Oh,
remove
remove
the
F.
condition at the start.
False. Wait, let me print this. What is print? Print. Oh, it's a result. Sorry, guys. Result with string. Yes. Okay, let's print string, see what is there. And let's print this string, see what it is.
I think you should be comparing result with result.
What the hell?
Result, you have to compare result with result.
Result with result.
Oh, yes, you're right. You're right. Because the result is the clean string. So let's say clean string. Yes. It makes sense now. True. Okay, that's cool. But is this gonna like accept it? Let's see. S, we have S, so we can use it here. Remove this, and then gonna return this.
Change string to S.
Okay, we can do it here. I believe it's reversed the string. Let's test it here. Let's do this string and let's print string and then print string. So it's reverse, like 1, 2, 3, 4, 5, 6, 5. That's crazy. Python is crazy. Okay, is this true? Run. Okay, it works. Submit. Ooh, 98. Wow. Clap for you guys. Okay.
I don't know for some reason I'm just always scared of this regular expression.
Yeah. We can do it in another way.
Yeah, but it's nice. I like it, but I'm just scared of it.
I think if the other way wanna do it with other way, it's gonna be like 2-pointer, and we just keep going checking if it is with this is alnum, which check if alphanumerical, and you keep going just comparing the character. We can jump to this third LeetCode, or we can do this one with the 2-pointer. Let's see. 2-pointer, redo with 2-pointer, jump to LeetCode. Next LeetCode, react with star on the one that you want. Okay, everyone wanna jump. Okay, let's jump.
Yeah.
Okay, so this LeetCode, given the root of a binary tree, invert the tree and return its root. Okay, so we have a root for 4, 2, 7. Okay, to become 7, 2, and for the child 7, it was 6, 9. It's become 9, 6. So we already feel like a recursion here, right? Like if we go maybe, okay, let's continue. Then here we have 2, 1, 3, 2, 1, 3, become 2, 3, 1. Interesting. Let's take this example to our lab and paste it. How we can do this? There is a feeling of recursion here. Any thoughts? Wait, let's see how the what the function they give us. To keep this function close to us, so we can imagine. So we have a tree node. This is our tree node, and it have value. It have left and right, and basically our inventory have a root. Let's take this node. Okay. So invert left, invert right, switch left and right. Wait, what this mean? Invert left, invert right, switch left and right. Oh, you wanna elaborate?
So basically, yes. So basically, you use a recursion as you said, and you send it with the left node, you send it with the right node, and at the very bottom of the tree, at the leaves, you switch the left and the right one, and as it goes up, it keeps switching.
Okay. Okay. Let's try to do it. Let's try to visualize it. So, if we say this is recursion, it's gonna be like this. Or I hope it's gonna be like this. So we start in the root, we do a call on the recursion function, which is this. We give it, we do actually two call because we have two child. So we do two call, one in the right, one in the left. Now the right, we give it this as a root, and the left, we give it this as a root, right? And this, then this also gonna do two call. It's gonna do one to the right, one to the left, one to the left, one to the right. And the right is gonna pass as a root the 9, right? And this gonna pass 6, and this gonna pass 3, and this 9 itself again, it's gonna do two calls. And these two calls, then these two calls. And because 9 doesn't have any child, it's gonna stop there. So maybe this is our base case. Like if there is no... if like there is... we can do like if the root is none, or if the... yeah, we can let this call go, and in the base case if the root is none, because this have child none. So we find our base case is if root equal none. What's it supposed to do? Like return none?
You just return.
Return none. I'm not sure if this root equal none is something like this, or is if root is none. I think it's none.
It's none, yeah.
Okay, so if the root is none, this is our base case for our recursion. Okay, now we said that each function is gonna call for this and this. So let's write that part of code. So it's gonna be invert tree, invert tree, and then here I should pass the left and the right, the other one. So this one I'm gonna pass the left, this one gonna pass the right. Let's say right,
root dot
left,
root dot right.
root dot right. Okay, root dot right, root dot left. But I need to flip them because now this is just, it needs to flip them, right? So I guess I invert left and right, switch left and right. So we can do the flip thing?
Are we doing it after we have gotten to the end of after we have gotten to the end, right?
After we got to the end.
Okay.
No, we're gonna convert here before. We're gonna convert.
Okay.
Then we're gonna launch.
Okay, so we can use something like root.right, root.left equal root.left, root.right.
Oh, the tuple switch. Oh yeah. Okay. So we can use the tuple switch. This is tuple switch, right? I think.
Yeah.
So roots.left roots.right equal roots.right equal root.left. So by doing this, we don't need like a temporary variable to save. It will switch automatically.
Yeah.
Okay, so this gonna switch and then call recursion, and this gonna all flip. They're gonna flip each other. Okay, let's go. Let's try it. Run. Right. Root, that's right. What was the error? Oh, I mistakenly write invert 3. So, oh, self, I think. Self. Oh, we have wrong answer. Or return root. Wait. Why? Okay. Oh yeah, we flip them. We should return. Yeah. Because this should return to this, and this should return to this. After it flip them. Yeah. So return root. Because we flip them here, and then we call another recursion, like we said here. This is gonna call this. This is gonna call this. And then it's gonna wait all this come back with return. Run. Hey, look at that. Be ready to clap. 55. Hey, nice work, guys. We solved 3 LeetCode.
Can I see another case?
Yes, please go ahead.
Let me just see another. I want to see another case, like another example. I just want to see. I want to compare something. Is there any other example they gave? Any other test case?
Yes, like here in this one.
Just want to see something. Okay.
Yeah, if you have question, we can.
It's okay. Like, can I see another one? Sorry, just these two. Is it just these two they gave us?
Yeah, they give these two.
Only two.
And this 3 that is empty.
Oh, empty, exactly. I get it. Don't worry, no, it's fine. I wanted to just compare some results. Okay, thank you.
Yeah, maybe share with us if you have like some idea. Like, do you have like some idea or something?
If I had seen another example that has a longer range, I would have found something. But it's okay. Let's work with it.
We can check here solution, see at least one how they do it. Let's just randomly check this one.
Because what I notice is if you have just a root and a child, you have just. Can you hear me?
Yes.
If you have just a root and his children, all you just needed to have just done was just to flip his children. That's all. And if you had a root and the children has other children, all you have to do is just to, first of all, flip the children, then reverse the rest. That's all. That's what I noticed. But it's okay.
Wait, isn't that what we did? We flipped the children.
That's what I'm saying. That you use recursion. Yeah, it could have also actually worked iteratively as well.
Oh.
Okay. Yeah,
okay.
that's fine.
Okay. This one also use recursion, but this one they swap the node after. Okay, how does that work? Is it like you can swap the node after? I think you can, but okay, yeah, it's work. Okay, I mistakenly think that it will not work if we swap before or after. I guess they're the same. Do you have the code for the iterated way? I do not have, but we can check if someone here does it iterated way. Okay, so there is iterated way. Try to see how it works. So he used stack, and then he looped through that stack. He puts the node in. Wait, we did something similar to this, I think. Okay, so he did pop that node. Then we did something like this in queue and stack. And then he switched the same way we did. And basically he check if it have left or right. He added to the stack. And he keep looping. So basically he keep looping on each node, flipping them. Rewrites the code here. Okay, 30 person here. Thank you for joining. Please, if you have something you want to say, go ahead. Have any question before we end?
Thank you, boss. Thank
today, you are the boss. Before ending today session, before you go, we also gonna do another session Saturday. Yes, Saturday. We're gonna see valid anagram, binary search, and flow. This is also 3 LeetCode we're gonna solve. So each week we're gonna solve. Each week we have 4 PLD, and each PLD we solve 3 LeetCode. And at the end of this 12 week or 3 months, we should be able to solve this hard one. That is the goal. Okay, have a good night, everyone. Have a good night. Thank you everyone for joining.